Okay, today's lecture is mainly for the students of 10th standard who are preparing for their board exams, and the topic for today's lecture is trigonometric identities. Okay, all of we know that there is always going to be questions from trigonometric identities and we always find it difficult. Okay, so in this lecture we are going to discuss a very easy approach to understand and to learn the trigonometric identities first of all, and how to use them while solving the questions. Now in all those questions there are some number of questions which can be solved like in multiple ways, but there are few questions which have a very fixed way to solve. Okay, so we are going to discuss all such type of questions in this lecture. Secondary, I'll simultaneously while solving the questions I'll give you a note that where we need to be cautionary and how to solve and how to apply the identities in a very suitable way. Okay, so let us start with the formation of the identities. The topic is trigonometric identities. Let us try to derive these identities. First of all, we know that in the 10th standard you are going to understand or you're going to study the topic of trigonometry in a right angle triangle. Okay, so let's take a right angle triangle. Let's say this is a right angle triangle at C, where C is the angle theta. Okay, this angle is 90 degree, angle B. We know that side opposite to 90 degree is hypotenuse. If this is angle theta, then the side opposite to angle theta, where theta is the angle under consideration or the base angle, side opposite to theta is perpendicular, and the side which contains 90 and theta, that is called the base of the triangle. Okay, so in this right angle triangle, how do we define sine theta? We know that sine theta is nothing but perpendicular upon hypotenuse, cos theta is nothing but base upon hypotenuse, and tan theta is equals to perpendicular upon base. Those who remember the phrase, it is observed some people have curly brown hair through proper brushing. Okay, that's how we learn and that's how we remember the three identities. The rest of the three identities are just the reciprocal of these three identities. We are not going to go into that detail, but today's topic is all about trigonometric identities. Now if I start in a right angle triangle, we know that there is one property which always holds in a right angle triangle, and that is your Pythagoras theorem. So as per the Pythagoras theorem, we have perpendicular square plus base square is equals to hypotenuse square. Now using this Pythagoras theorem, we are going to derive each and every identity. Okay, so let us start with the first one. What I'm going to do over here, I'm going to divide both sides by h square. Okay, so if you divide both sides with h square, your left hand side is going to be p square by h square plus b square by h square, and that is equals to h square by h square. Okay, so this is nothing but p by h whole square plus b by h whole square, and that is equals to 1 on the right hand side. I hope this is quite easy to understand. आपने simple Pythagoras theorem apply की, and what you did over here, that you have divided both sides with h square to get this result. Now what is p by h? Observe over here, p by h is sin theta, so ये बनेगा sin theta whole square. Sin theta whole square. What is b by h? b by h is cos theta and square of this, and this is equals to 1. So your first identity is this square will come और ये sin के ऊपर आ जाएगा, sin square theta plus cos square theta equals to 1. This is your first identity जो हमने simply Pythagoras theorem को use करके derive किया. Alright, so I hope this thing is clear. You can always stop the video and try to develop the whole identity on your own. Okay, wherever you find it difficult, you can always look for the steps. Now I can use this identity to derive the other versions also, but let us say we start again with the first step. Again using the Pythagoras theorem, I'm taking the same triangle C over here with the angle theta. This angle is 90 degree and this is A. Once again, if I have the identity p square plus b square is equals to h square. This time what I'm going to do, I'm going to divide both sides with, let's say, b square. Okay, so b square से अगर divide करें, divide both sides with b square. So what I have, p square upon b square plus b square upon b square is equals to h square upon b square. Okay, this will cancel out to give you 1. This is nothing but p by b whole square, and this is equals to h by b whole square. All right, so all of you know that what is p by b? P by b is tan theta perpendicular upon base plus 1, and we know that b upon h is cos theta, but in this case it is h upon b, which is nothing but secant theta. So secant theta whole square. So this gives me my next identity, and it is nothing but tan square theta plus 1 is equals to secant square theta. So that's your second identity. Got it? So I hope it is quite clear now कि आपने एक बार h स्क्वायर से डिवाइड किया तो फर्स्ट आइडेंटिटी को डिराइव किया, b स्क्वायर से डिवाइड किया तो आपने tan स्क्वायर थीटा प्लस 1 इक्वल्स टू secant स्क्वायर थीटा को डिराइव किया. Now if I go once again with the same steps, पाइथागोरस थ्योरम से स्टार्ट करेंगे. This time we are going to divide both sides by p स्क्वायर. एक यही लेफ्ट आउट था, p स्क्वायर से डिवाइड करते हैं, p स्क्वायर अपॉन p स्क्वायर, b स्क्वायर अपॉन p स्क्वायर and h square upon p square. But you are going to get 1 plus b by p whole square is equals to h by p whole square. What is b by p? It is nothing but cot theta. So cot theta whole square aa gaya. H by p is nothing but cosec or cosecant theta. So this is the case. So what I am going to get? 1 plus cot square theta is equals to cosecant square theta. That is your third identity. Okay, so तीन ही आइडेंटिटीज आपके पास है, तीनों को हमने बहुत ही इजी वे में डिराइव किया है एंड वी गॉट द एंटायर रिजल्ट बिफोर अस. ओके, नाउ लेट अस ट्राई टू start with once again with the first identity and let us see how even without using this entire concept you can derive that first identity into the other two, and we are also going to study the derived versions of each of the identities. So our first identity was sin square theta plus cos square theta equals to 1. ये हमारे पास फर्स्ट आइडेंटिटी है. आपने देखा होगा डायरेक्ट आइडेंटिटीज यूज में कम आती हैं, बट उनके जो न्यू सेट ऑफ रिजल्ट्स हैं, फॉर्मुलेटेड रिजल्ट्स हैं या जो डिराइव्ड रिजल्ट्स हैं, वो आपके पास यूज में आते हैं. तो कैसे बनेगा? इफ आई टेक sin square theta to the other side, so cos square theta is nothing but 1 minus sin square theta. I'll say that this is another sub result for this thing. Okay, and once again if I take cos square theta to the other side, it will give me sin square theta equals to 1 minus cos square theta. This is another result. Okay, so आपने फर्स्ट आइडेंटिटी को दो अदर डिफरेंट वे से लिखा एंड यू कैन ऑलवेज यूज दीज टू वर्जन्स व्हाइल सॉल्विंग द क्वेश्चन एंड यू विल सी जब हम क्वेश्चन सॉल्व करेंगे तो कैसे इनकी एप्लीकेशंस में भी यूज आता है. ओके, नाउ सेम वे से हम लोग सेकंड आइडेंटिटी को पिक करते हैं. सेकंड आइडेंटिटी हमारे पास क्या थी? 1 plus tan square theta equals to secant square theta. These are second identity. Another way, or I can rewrite this identity as secant square theta minus tan square theta equals to 1. ये एक वे आ गया इसको लिखने का. एंड आई कैन ऑल्सो राइट इट लाइक दिस, that secant square theta or let's say tan square theta लिखते हैं, tan square theta equals to secant square theta minus 1. This is another way to write this thing. Okay, so second identity को भी हमने टू डिफरेंट वे से लिख के ऑब्जर्व किया. ओके, अब आप लोग मिस्टेक कहां पे करते हो? वी शुड रिमेंबर कि जो tan square theta है दैट इज secant square theta minus 1, नॉट 1 minus secant square theta. आप लोगों में से मैंने देखा है मोस्ट ऑफ द स्टूडेंट्स जब भी एग्जाम में इस चीज को अप्लाई करना है, इंस्टेड ऑफ secant square theta minus 1 दे यूज 1 minus secant square theta. सो इट्स अ कॉशनरी पॉइंट, गलती होने के चांसेस होते हैं, तो यहां पे आपने ध्यान रखना है. ओके, सो इट इज secant square theta minus 1 for equal to tan square theta. Now let us move to the third identity. So third identity was 1 plus cot square theta equals to cosec square theta. Again, let's rewrite this thing. I can rewrite this thing as cosecant square theta minus cot square theta equals to 1. And I can also write this thing as that cos square theta is equals to cosecant square theta minus 1. This is okay. So the derived versions of the identities are also before you. Okay, based on the concept that we have discussed so far, the identities, trigonometric identities, now we are going to discuss few questions based on the identities. So all these questions are important as far as exam is concerned. And mostly these are the questions which I have picked, which they come frequently in the board exams. Okay, so let's start with the solution part. Your first question is that if secant theta plus tan theta is equals to p, then prove that sin theta equals to p square minus 1 upon p square plus 1. Okay, so let us try to solve this question. The question involves secant theta and tan theta. The addition of these two numbers is equal to p. How we are going to proceed with the solution? We need to observe the identity which covers secant and tan. Okay, so if we recall, we have an identity secant square theta minus tan square theta equals to 1. I hope you remember this thing. Now in this identity, if you observe, we can apply the identity of a square minus b square, which is going to give me a plus b into a minus b. Alright, so this is the very first step that you need to remember. So note this step, that how you're going to start with the solution. Okay, this is the very step that you need to remember. Now in this case, secant theta plus tan theta times secant theta minus tan theta equals to 1. The value of this first factor is equals to p. Alright, from the given condition, this is p times secant theta minus tan theta. So this is equals to 1. That gives me secant theta minus tan theta equals to 1 by p. Now if I say this is my first equation and the given equation secant theta plus tan theta equals to p, that is your second equation. If I add these two equations, on adding these two equations, I am going to get something that on adding these two will cancel out and I have 2 secant theta equals to p plus 1 by p. Okay, so this gives me that secant theta is equals to half of p plus 1 by p. Let's mark this with one of the important equation. Okay, now for such type of questions, now this question can be asked in different ways. Like under 1 mark category, you will get this data and they will ask you to find the value of secant theta. So we got the value of secant theta, or they can ask you to find the value of tan theta. For tan theta, let's once again rewrite the two equations. अब मैं second equation additionally पहले लिख लेते हैं. This is equals to p and secant theta minus tan theta equals to 1 by p. Okay, now instead of adding, if I subtract these two equations, this is minus, this is plus, and this is minus, these two will cancel out. So you are going to get 2 tan theta equals to p minus 1 by p, and that gives me that tan theta is equals to half of p minus 1 by p. Okay, so they can ask you to find the value of tan theta or secant theta. Secant theta हमने पहले find out किया, tan theta हमने यहाँ पे obtain किया. Now overall अगर क्वेश्चन देखा जाए, in the current question I need to prove that sin theta is equals to p square minus 1 upon p square plus 1. Okay, but I just got the value of secant theta and tan theta over here. So this is the first value and this is the second value that I got. But for sin theta, how we are going to proceed, that's the question. Okay, sin theta, if you observe from these two equations, secant and tan, can you say, observe that if I write sin theta as tan theta, it is going to have an extra cos in the denominator, okay? Because we know tan theta is sine by cos. So if I simply get rid of that cos by taking or by writing secant theta in the denominator, so this forms a relationship between sine, tan and secant, okay? So you can always check करके देखें जरा इसको, that tan theta upon secant theta, ये क्या बनेगा? This is going to be sin theta by cos theta. Okay, ये किसको लिखा मैंने? Tan को लिखा. This tan theta is entire this part, और जो secant theta है, that is nothing but 1 upon cos. Okay, this is your secant theta. These two will cancel out, and eventually this is equal to sin theta. So this is how you are going to observe that sin theta is nothing but the ratio of tan and secant. Okay, tan upon secant. Why I'm doing this thing? Because I got the value of tan theta as half of p minus 1 by p, and I got the value of secant theta over here as half of p plus 1 by p. Half and half cancels out. If you take the LCM, it is p square minus 1 upon p whole upon p square plus 1 upon p. These two will cancel out, and what's the final answer? The final answer is nothing but that this sin theta is equals to p square minus 1 upon p square plus 1. Okay, and hence proved. So I hope this thing is clear to you. The question is important. I have taken this as the very first question so that you are easily able to understand the questions. We are only going to discuss the most important questions from the board point of view, okay, from the perspective of your board exams or pre-board exams. These are the questions which are mostly asked in the exam. Okay, let's move to the next one. Okay, let's take another question based on the same concept. Okay, we just solved a question involving tan and secant. Now we got a question involving cosecant and chord. So why I'm explaining to you this question? Because similar kind of questions can be asked in your exam. अब यहाँ पे हमने same process से apply करना है. What was the first step in that case? We started with the identity involving cosecant and chord. So the identity is cosecant square theta minus chord square theta equals to 1. Okay. In this case, अब इस identity को हमारे पास कैसे करेंगे? Once again, we are going to break this down using the identity of a square minus b square. So if you got this thing, this is going to be cosecant theta plus chord theta into cosecant theta minus chord theta equals to 1. I hope this thing is clear. किसकी वैल्यू हमारे पास अवेलेबल है? Cosecant theta plus chord theta is p. Let's put this as p and then into cosecant theta minus chord theta, and this is equals to 1. So therefore I got cosecant theta minus chord theta equals to 1 by p. That's your first equation. Okay. Second equation अगर देखा जाए तो given equation को हम second consider कर रहे हैं, cosecant plus chord. We got cosecant theta plus chord theta equals to p. क्या किया था हमने equation में? Just recall we added these two equations. अगर मैं दोनों equations को add करूँगा तो क्या आएगा? These two will cancel out. Adding these two will cancel out. एक negative एक positive है, and on the left hand side I'm going to get 2 cosecant theta. This is equals to p plus 1 by p, and this simply gives me the value of cosecant theta as half of p plus 1 by p. Okay, let's mark this as an important equation. We are going to use it later on, but for the time being we got the value of cosecant theta as half of p plus 1 by p. What is the next step? The next step was that we are going to rewrite the equations. The second one at the top, positive value ऊपर लिख लेते हैं, cosecant theta plus cot theta equals to p and cosecant theta minus cot theta equals to 1 by p. Initially हमने addition किया है, now we are going to subtract the two equations. Okay, let's subtract. This positive will become negative, negative will become positive, and this is again negative. These two will cancel out and you got yourself 2 cot theta on the left hand side, cot plus cot, and on the right hand side it will be p minus 1 by p. Now therefore you got the value of cot theta as half of p minus 1 by p. Okay, this is your second most important equation. But our target once again is not finding the value of cosecant theta. That may be in your exam that if you can get a question under 1 mark category that find the value of cosecant theta if all the same data is given to you, or you can need to find the value of cot theta. But here I need to find the value of cos theta. Now cos theta is nothing but the ratio of cot upon cosecant. Alright, what is cot theta? Cot is half of p minus 1 by p. What is cosecant? It is half of p plus 1 by p from the earlier results. Okay, this is cosecant and this is cot. We have just substituted over here, half and half cancelled out. If I take LCM, this will be p square minus 1 upon p, whole upon p square plus 1 upon p. This p and p will cancel out, and therefore cot theta equals to p square minus 1 upon p square plus 1. This is what I need to prove, hence proved. So I hope from these two questions, one thing should be clear to you, that how to solve such kind of questions. Okay, it will be there in your exams. 90% of the times this question comes in your pre-boards as well as in board exams. Okay, difference क्या होगा, यहाँ p की जगह कई बार m आ जाता है, कई बार कोई और variable होगा, so that's the only difference. Okay, our third question is prove that sin theta minus cos theta plus 1 upon sin theta plus cos theta minus 1 equals to secant theta plus tan theta. Again one of the most important question. Okay, how to solve this question is one of the question यहाँ पे आपको steps को याद रखना पड़ेगा. Okay, there is no alternative way to solve the question. So if you try it with another way, you may not end up with the final solution. So you have to remember each and every step starting from the very beginning. Okay, so the question says that I have an expression on the left hand side involving sin and cos, but on the right hand side I need to involve secant theta plus tan theta. So if you remember, what is tan theta equals to? Tan theta is equals to sin theta upon cos theta. This is what we have for tan theta. अगर मेरे को tan involve करना है तो मेरे को sin upon cos involve करना है, and that is the first key step to our solution, that for the left hand side divide numerator and denominator by cos theta. Okay, why cos theta? Because I need to involve tan theta and I know sin by cos is tan. Okay, तो कैसे करेंगे? Each term को आपने cos से divide करना है. This is sin theta by cos theta minus cos theta by cos theta plus 1 by cos theta whole upon you have sin theta by cos theta plus cos theta by cos theta and minus 1 by cos theta. Okay, the solution doesn't involve that many steps. Hardly 4 to 5 steps are sufficient for the solution, but you need to remember each and every step. Okay, so once I have divided both numerator and denominator by cos theta, what I'm going to get, sin by cos is tan. This is nothing but 1 plus this is secant theta. Okay, this, observe, now the solution has started to take the shape of the desired expression. Okay, हमें tan और secant involve करना है. We got tan and secant, but it is not exactly what I need. What I have over here so far is tan plus secant, tan theta plus secant theta minus 1. I have shifted this negative 1 at the end and I have clubbed secant and tan. Even in the denominator I can say tan theta minus secant theta plus 1. Okay, आपने expression को rewrite किया. Now the next step that we need to remember for this solution is that we need to substitute the value of 1 in the numerator in terms of tan and secant. Okay, so if you remember the identity, what is the identity? The identity in terms of tan and secant is secant square theta minus tan square theta equals to 1. Okay, so if I apply this identity, how I'm going to proceed? This 1 that I have in the numerator, I'm going to write this 1 as tan theta. Okay, next thing that you can try is कि आप tan plus secant को ना secant plus tan लिखो. उसका reason ये होगा क्योंकि आइडेंटिटी में ना सीकेंड यहाँ पे पहले आ रहा है. सो सीकेंड थीटा प्लस टैन थीटा माइनस सीकेंड स्क्वायर थीटा माइनस टैन स्क्वायर थीटा. अब ये किसके लिए लिखा हमने? वी हैव रिटन दिस थिंग in place of 1 in the numerator. ये जो 1 है इसकी जगह हमने कौन सी आइडेंटिटी का यूज किया? secant square theta minus tan square theta equals to 1 and the denominator part remains the same. No need to change the denominator. This is what you need to remember. Denominator में जो 1 है we are not going to do anything with it, but numerator में जो 1 है उसकी जगह हमने secant square theta minus tan square theta replace किया. Okay, what else? ऑब्वियसली आपको आइडेंटिटी ढूंढनी है. कौन सी आइडेंटिटी लग रही है यहाँ पे? अगर ध्यान से देखा जाए ए स्क्वायर माइनस बी स्क्वायर. एज पर द आइडेंटिटी इट इज सीकेंट थीटा माइनस टैन थीटा इनटू सीकेंट थीटा प्लस टैन थीटा. ओके, आई नीडेड स्पेस, दैट्स व्हाई मैंने स्पेस यहाँ पे बनाई है. दिस इज टैन थीटा माइनस सीकेंट थीटा प्लस 1. ओके, सो आई थिंक फ्रॉम द फर्स्ट स्टेप अगर हम रिकॉल करें या रिव्यू करें, सो द फर्स्ट स्टेप वाज टू इन्वॉल्व सीकेंट एंड टैन. सीकेंट एंड टैन इन्वॉल्व करने के लिए हमने क्या किया? वी डिवाइडेड बोथ न्यूमरेटर एंड डिनोमिनेटर विद cos थीटा. हमने sin बाय cos टैन, 1 बाय cos सीकेंट एंड दिस कैंसिल आउट करके 1 आ गया. देन वी सेपरेटेड 1 टू द एंड और न्यूमरेटर में जो 1 था उसकी जगह हमने फिर से आइडेंटिटी को अप्लाई किया. नाउ कम्स द अनदर पार्ट व्हिच इज रियली इंपॉर्टेंट एंड वेयर समटाइम्स स्टूडेंट्स मेक मिस्टेक और दे गेट कंफ्यूज्ड. The thing is this first factor is my first term and this entire product of two factors is the second term. From first and the second term you need to take something common. Observe करो क्या common आ रहा है? आपके पास आ रहा है secant theta plus tan theta common. जैसे common लेंगे I'm going to start with the square bracket. From the first term जब भी आप common लेते हो you know जितनी number of terms, the number of terms that we have earlier before taking common, same number of terms will be left out even after taking common. Okay, so there are two terms, term number 1 and term number 2. term 1 से हमने पूरा factor common लिया तो उसकी जगह क्या बचेगा? only 1 minus then term 2 में से हमने secant plus tan common लिया and we are left with secant theta minus tan theta over here. In the denominator I'm going to have tan theta minus secant theta plus 1. All right, so I hope till this point it is clear to you. Now comes the final step of the solution. आपके पास क्या है? secant theta plus tan theta. I'm going to open up the terms inside the square bracket. 1 minus secant theta and minus minus plus tan theta. And in the denominator you have tan theta minus secant theta plus 1. This entire factor cancels with this one and you are left with your secant theta plus tan theta. And that is the right hand side of the whole solution. So this completes the entire solution. Okay, moving on to the next question what we have over here, that if sin theta plus cos theta is equals to root 3 then prove that tan theta plus cot theta equals to 1. Okay, again important questions जो आपके NCERT में directly questions हैं, you should practice those questions, but it may not be the case कि आपको same questions as such board exams में आए या school exams में आए. Okay, so for that all the other set of questions which have the potential, which are most frequently asked in your exams, मैंने वो सारे के सारे क्वेश्चन इस लेक्चर में रखे हैं and I hope you are going to solve them properly before you are going to go for your exam. Okay, so given condition is that sin theta plus cos theta equals to 1, equals to root 3. ये आपके पास given है. वैल्यू मेरे को फाइंड आउट करनी है tan theta plus cot theta की. Let us see कि अगर मेरे को tan theta plus cot theta के लिए इसको प्रूव करना है, so if I start with the left hand side, what I'm going to get? You know tan theta is sin theta by cos theta, cot theta is cos theta by sin theta. Alright, if you take LCM over here, what will you get? Cos theta into sin theta, and in the numerator this will be sin square theta and here plus cos square theta. Okay, you know sin square theta plus cos square theta is 1 and the final step that so far I am getting is 1 upon cos theta into sin theta. Okay, this is the step I have. Now in order to prove that this entire expression is equals to 1, this is what I need to prove. I need to find the value of cos theta into sin theta. Let's see how we are going to manage that part. From here I got sin theta plus cos theta equals to root 3. I need the product of these two values, but I got the sum of these two values. So आपने क्या करना है? You'll apply squaring both the sides. Let us see how we are going to manage the value of sin theta into cos theta by applying squaring both sides. Here we have sin theta plus cos theta whole square equals to root 3 square, and this is going to be sin square theta plus cos square theta. कौन सी आइडेंटिटी लगेगी? a plus b whole square, which is a square plus b square plus 2ab. So I have over here 2 sin theta into cos theta and that is equals to 3. Okay, root 3 का square 3 आ गया. Now the value of sin square theta plus cos square theta is equals to 1. All of you know this thing. This is 1 plus 2 sine theta into cos theta equals to 3. From here I can get the value of 2 sine theta cos theta. This is equals to 3 minus 1, which is 2. And this 2 again will go in the denominator. In the next step, to give me the value of sine theta times cos theta. So I got the value of the product of these two as 1. And if I substitute this value over here, 1 upon 1 equals to 1, you can mention the reason, because as per the simplification, sine theta into cos theta turns out to be 1, which is your right hand side. So that is how we are going to prove this thing. Okay, so our question is cos square theta upon 1 minus tan theta plus sine square theta upon 1 minus cot theta is equals to 1 plus sine theta into cos theta. This is what we need to prove. Let us proceed with the solution. Starting with the left hand side, what we have over here, cos square theta upon 1 minus tan theta. So see, on the right hand side we need answer in terms of sine and cos. So we are going to change everything into sine and cos. If it is not, like for tan theta I can write this thing as sine theta by cos theta, and cot theta I can write cos theta by sine theta. Alright, so I got the value of tan as sine by cos and cot as cos by sine. What else? After this, what we are going to do, we are going to take LCM in the denominator section. So in the denominator, cos theta is the LCM for the first part, and this is going to be cos theta minus sine theta. In the second one, the numerator is still sine square theta, but in the denominator, if I take LCM, it is 1 minus, not 1 minus, sine theta minus cos theta. Okay, so first step was to change tan into sine by cos, then cot into cos by sine. All right, and in the second step, in the denominator of both the terms, we have taken LCM. Now, this is your actual division. It means if I divide this cos square theta with this one, this cos is going to go multiplied with the numerator. So I'm going to get cos cube theta upon cos theta minus sine theta. Similarly, for the next term, I'm going to get sine cube theta upon sine theta minus cos theta. All right. So first step के बाद आपके पास जो later on के steps हैं वो step by step on their own they are going on. Okay, आपने LCM लिया, shifting की, and you got till this step. अब observation क्या है? That the denominator of each of these two terms are same but opposite in sign. One is cos theta minus sine theta, another is sine theta minus cos theta. So for that reason, what I'm going to do in order to make them same, I'm going to take a negative sign common from the denominator of the second term. So if I take negative sign common, this sine minus cos will become cos theta minus sine theta. I hope this thing is clear to you. A minus b में से जब आप negative sign common लोगे तो वो b minus a बनेगा. And here it is sine cube theta. And what this negative sign is going to do, this is going to move to this part, और ये इस plus sign को negative में convert करेगा. So next step is going to be that this is cos cube theta whole upon cos theta minus sine theta minus sine cube theta whole upon cos theta minus sine theta. Just observe what we have achieved. दोनों के denominator अब क्या है? Same आ चुका है. Cos theta minus sine theta and cos theta minus sine theta. And you know once we have the same denominator, LCM लेना उतना ही आसान होगा. तो क्या लिखेंगे? Cos theta minus sine theta as a LCM in the denominator, and in the numerator we have cos cube theta minus sine cube theta. Okay. In the numerator, we are going to apply the identity for AQ minus BQ, which is A minus B into A square plus B square plus AB. Make sure to remember this identity. And if I apply this identity in the numerator, it will be cos theta minus sine theta into cos square theta plus sine square theta plus cos theta into sine theta whole upon cos theta minus sine theta. I hope numerator में identity आपको observe भी होगी. This is cos cube theta minus sine cube theta, which is nothing but a cube minus b cube, and it is simply a minus b. So for that, cos theta minus sine theta times a square plus b square plus ab, cos square theta plus sine square theta plus cos theta sine theta. And if you observe, this whole factor will cancel out. आप जब भी trigonometric identities को solve करते हो, we can only cancel out the factors from denominator and the numerator. We can never cancel out the terms. Most of the students that may make this mistake. So make sure you should not. Cos square theta plus sine square theta, this entire term will be 1, and rest I have cos theta times sine theta. Okay, and this is what I need to prove. So this is the right hand side of your solution, and hence we have proved the entire result. Okay, our next question is if cos theta plus sine theta equals to root 2 cos theta, then show that cos theta minus sin theta equals to root 2 sin theta. Okay, cos plus sin theta की वैल्यू आपके पास गिवन है और cos theta minus sin theta की वैल्यू आपने निकालनी है. That's the question. अब इसके लिए ट्रिक्स हो, मल्टीपल ट्रिक्स हैं. I'm going to give you a best trick to solve the question. कैसे करेंगे? सबसे पहले हमने क्या करना है? We'll start with the given condition. This is the given condition. Cos theta plus sin theta equals to root 2 cos theta. Okay. Apply squaring both the sides. Squaring both sides. What will you get? On the left hand side we'll have sin theta, cos theta plus sin theta whole square, and on the other side I have root 2 cos theta whole square. Okay, so ध्यान से देखो, प्रूव क्या करना है आपने? cos theta minus sin theta equals to root 2 times sin theta, यानी कि यहाँ cos की जगह sin आना चाहिए और यहाँ प्लस की जगह माइनस sin आना चाहिए. Okay, that's the reason हमने यहाँ squaring अप्लाई किया. If I apply the identity a square plus b square plus 2ab, and this is equals to 2 cos square theta. Got the point? आपको करना क्या है? आपको सारी के सारे टर्म्स देखो, सिंपल सा वे है इस क्वेश्चन को सॉल्व करने के लिए, दैट we are going to change every cos square theta into sin square theta. But I'm going to write it over here as 1 minus sin square theta, 1 minus cos square theta plus 2 times cos theta sin theta, इसमें कोई चेंज नहीं करनी, and on the right hand side 2 times 1 minus sin square theta. Okay, क्या किया आपने? आपने सिंपल वे में sin square theta को 1 minus cos square theta लिखा as per the identity. आपने cos square theta को 1 minus sin square theta लिखा और sin square theta को 1 minus cos square theta लिखा. Now if I open up the value expression, this is going to be 1 minus sin square theta plus 1 minus cos square theta plus 2 cos theta sin theta, and on the other side also 2 minus 2 sin square theta. Okay, this is what we are going to get. Now I'm going to shift all the terms to, we are going to simply shift the terms from right to left and left to right. Okay, उससे पहले I think we should go with the simplification. 1 plus 1 is 2 minus sin square theta minus cos square theta plus 2 cos theta sin theta equals to 2 minus 2 sin square theta. Okay, this 2 will cancel out with this one. Left side with positive 2 है, right side with positive 2 है, they will cancel out. Now I'm going to shift all these terms to the other side and bring that 2 sin square theta from right to the left hand side, and this is equals to sin square theta plus cos square theta, and this is the positive term, it will shift to the other side to become minus 2 times cos theta into sin theta. 2 sin square theta on the left hand side, this is a square plus b square minus 2ab, which is nothing but a minus b whole square. Now instead of sin I am taking cos square theta as a square plus b square minus 2ab. रीजन क्या है? आपको cos minus sin theta की रिक्वायरमेंट है, so cos theta minus sin theta whole square is equal to this. One final step and we are done with the whole solution. It says that, let's rewrite this step. Cos theta minus sin theta whole square is equals to 2 sin square theta. Now if I shift this 2 to the other side, it will give me cos theta minus sin theta equals to root 2, क्योंकि 2 का जब रूट होगा तो root 2 होगा और sin square theta का रूट होगा, that will be sin theta. Okay, and this proves the entire result. So I hope you got the concept कि आपने beginning से लेके end तक क्या किया. Let's once again review the whole solution. Cos theta plus sin theta equals to 2 root 2 cos theta. This thing is given to us. ये given था. आपने इसमें squaring both sides apply किया है to in order to get cos theta plus sin theta whole square equals to root 2 cos theta whole square. That will be a square plus b square plus 2ab equals to 2 cos square theta. Trick is only in one of the step. That trick involves कि आपने cos square theta को identity की help से 1 minus sin square theta replace किया, sin square theta को 1 minus cos square theta से replace किया. Nothing over here as such copy किया, क्योंकि एक cos है और एक sin है और उसके ऊपर कोई square नहीं है. No square, no identity. And on the right hand side you have 2 cos square theta, which again I have changed as 2 times 1 minus sin square theta. Okay, so I think this is pretty easy. Then you open up the brackets, this 1 plus 1 becomes 2, cancel out with the 2 on the right hand side. और फिर आपने यहाँ पे क्या किया? आपने shifting of the terms किया. वैसे तो आप नेगेटिव साइन कॉमन लेके भी कर सकते थे, बट आई हैव गिवन यू इजी वे कि आप सारी टर्म्स लेफ्ट साइड से राइट साइड पे शिफ्ट कर दो और राइट साइड पे जो एक सिंगल टर्म है 2 sin square थीटा उसको लेफ्ट साइड पे ले आओ, जस्ट टू चेंज द साइन ऑफ द टर्म्स. नेगेटिव पॉजिटिव हो जाएंगी, पॉजिटिव नेगेटिव हो जाएंगी, एंड बिकॉज ऑफ दैट यू आर गोइंग टू गेट ऑन द राइट हैंड साइड a square plus b square minus 2ab which is a minus b whole square. और फिर फाइनली आपने ये जो स्क्वायर है राइट साइड पे जैसे शिफ्ट किया, 2 का स्क्वायर रूट 2 हो गया, sin square थीटा का स्क्वायर रूट sin थीटा हो गया, एंड दैट प्रूव्स द एंटायर रिजल्ट.